Welcome to Video 15, Algebra 3. Now take a look at the board and tell me if you remember how to do this equation. Here we have 2/3 x equals 16. Do you remember what to do? When you have an equation like this, what you're going to do is you're going to flip over the 2/3, make it 3/2, and multiply both sides by 3/2, the opposite of 2/3. So let's do it. Here we have 2/3 x equals 16. And how am I going to solve this? I'm going to multiply by its opposite, by the inverted form, which is 3/2. Now when I do this, what happens? All of this cancels out. 3 into 3 is once, 2 into 2 is once, it becomes 1x. And on this side, I can cancel again. 2 into 2 is once, 2 into 16 is 8, and 8 times 3 is 24. And that means that 1x is 24, or x is 24. Do you remember that? Let's do one that's a little bit more difficult. Let's see. Let's erase the board, and let's do one that looks like this. Here we have 2/7 x plus 2/7 x, and it equals 20. What am I going to do? I'm going to combine like terms on this side of the equal sign. 2/7 x plus 2/7 x is 4/7 x, and that equals 20. Now what do I need to do to solve this? I need to multiply by its opposite. I need to flip around the 4/7 to 7/4, and I need to multiply on both sides by its opposite. So here we go. This cancels out. 4 into 4 is 1, 7 into 7 is 1, and we get 1x. And here we're going to cancel again. 4 into 4 is 1, 4 into 20 is 5, 5 times 7 is 35. So 1x equals 35, or actually x equals 35. Okay, let's go on for something just a little bit more difficult. Here we go. We have a problem. Are you ready? It's 1/5 x plus 3/10 x equals 27 minus 2/5 x. And what are we going to do? Well, we're going to have to bring over this 2/5 x over here. We're going to have to get rid of that 2/5 x. We want to have the x's on one side and the numbers on the other side. And how am I going to do that? I'm going to add a positive 2/5 x on both sides. Add a positive 2/5 x on both sides. Oh, excuse me, I'm putting this in the wrong place. Let's put it right here. Add a positive 2/5 x on both sides. And what happens is a minus 2/5 x and a positive 2/5 x, that just cancels out. Just cancels out. And on this side, 1/5 plus 2/5 will give me 3/5 x. And 3/5 x plus 3/10 x is going to equal 27. Now, I still haven't solved the equation. What do I need to do? I need to change my fifths into tenths. And how do I do that? I divide the bottom, multiply the top. I'm going to change 3/5 into tenths. 5 into 10 is 2. 2 times 3 is 6. That's 6/10 x plus 3/10 x. And what is that going to equal? 6/10 plus 3/10 equals 9/10 x. So let's go like this. And here we have 9/10 x equals 27. What am I going to do to solve this? I need to multiply by its opposite on both sides. Multiply by its opposite on both sides. This completely cancels out. And I end up with x equals, now look at 9 into 9 goes once, 9 into 27 is 3 times. 3 times 10 is 30. X will equal 30. Let's try another one. Let's see if you can do it. Let's try one that's a little bit more difficult, and let's see what you can do. Here's my problem. Are you ready? It's 4/9 c plus 2/3 c equals 17 plus 1/6 c. Now again, I need to get rid of this 1/6 c. I need to bring my letters on one side, my numbers on the other. And how am I going to get rid of it? I'm going to add a negative 1/6 c. Whatever I do to one side, I have to do to the other side. So this completely cancels out. And what am I left with? Well, I'm left with 4/9 C plus 2/3 C minus 1/6 C equals 17. Now what am I going to do? I need to change these fractions into fractions with like denominator. So I need a least common denominator. And what is the number that both 9, 3, and 6 will go into? The smallest number that 9, 3, and 6 will go into. It's 18. So let me change my 4/9 into 18s. Let me change my 2/3 into 18s. And let me change my 6 into 18s. And how do I do it? Divide the bottom and multiply the top. 9 into 18 goes 2, and 2 times 4 is 8. 3 into 18 goes 6, and 6 times 2 is 12. Let's make this a little, I'm going to erase this so we can see it a little bit better. There we go. Let's make this a little bit larger. So we had 9/18 C, and then we had 12/18 C. Oh, excuse me, no, it wasn't 9/18, excuse me, it was 8/18 C. And then we had, it was 1/6 that we're going to change. 6 into 18 goes 3, and 3 times 1 is 3. So we changed 4/9 into 8/18. 9 into 18 is 2. 2 times 4 is 8. And then we had 2/3, and we changed that into 18s. And how do we do it? 3 into 18 is 6. 6 times 2 is 12. And then we changed 1/6 into 18. 6 into 18 is 3. 3 times 1 is 3. So we changed 4/9 into 18s, 2/3 into 18s, 1/6 into 18s. Now, can we combine anything? Sure we can. We can combine 8/18 and 12/18. That's 20/18. And 20/18 minus 3/18, it's 17/18. So what do I have? I have 7/18 C equals 17. Excuse me, 17/18 C equals 17. 8 and 12 is 20. 20 minus 3 is 17. So here we go. Let's erase a little bit more. We've got 17/18 C equals 17. I'm going to multiply by its opposite. Multiply by its opposite. Here we go. This completely cancels out. And this cancels out over here, and I'm left with C equals 18. Now, I'd like you to get some practice. I need you to go to the Learn Math Quickly, Workbook 4. This is Algebra. Please do pages 38 to 39, that's part 1, and pages 48 to 49, that's part 2 in this. This is book 4. And come on back because we're going to be learning about how to handle 2 unknowns. So come on back for the next part. And now for something completely different. We are going to be solving an equation with 2 unknowns. Take a look at this. It's y equals x plus 6. We don't have just one unknown, we have 2, both y and x. What are we going to do? We're going to start with x. We're going to be assigning certain values for x. I just picked these, 0, 1, 3, and 5. And I'm going to be substituting it into the equation and seeing what y would equal. For instance, let's take a look. Y equals x plus 6. If x was 0, then what would y equal? 0 plus 6 is 6. Well, if x was 0, then y would equal 6. And what would happen to this equation if x was 1? Well, 1 plus 6 is 7. If x was 1 in this equation, y would equal 7. And what about if x equaled 3? Well, 3 plus 6 is 9. In this equation, if x was 3, then y would equal 9. And what about if x equaled 5? Well, 5 plus 6 is 11. So in this equation, if x was 5, then y would be 11. So what did we do? We substituted these values for x, and we said if we substitute this value, what would y equal? And these were our answers. Let's do another one. Let's see. Here we have y equals x plus 5. Now, if we say that y equaled x plus 5, and we made x 0. 0 plus 5 is 5. So y would equal 5. And what about if x equals 1? Well, then y equals 1 plus 5, or 6. And what about if x equals 2? Well, then 2 plus 5 is 7, and y would equal 7 when x is 2. We're substituting. Let's do another one. If y equals x plus 5 and x is 3, then 3 plus 5 is 8. Y would equal 8. So here we substituted these values for x, and we found out what y equals. So let's try it again. Let's take a look at a different equation. Here we have a multiplication in our equation. We have y equals 3 times x plus 5. These parentheses mean multiply, right? So let's say that we're going to substitute 0 for x. So that would be 0 plus 5. Now remember, we always do what's in the parentheses first. So 0 plus 5 is 5, and 5 times 3 is 15. So if x was 0, then y would equal 15. You see what I did? I said 3 times x plus 5. I substituted 0 for x. 0 plus 5 is 5, and 3 times 5 is 15. Let's do it again. Here we have 3 times x plus 5, and this time we're going to substitute 1 for x. 1 plus 5. 1 plus 5 is 6. So y is going to equal 3 times, let's do it like this, 3 times 6, and 3 times 6 is 18. So y would equal 18. 3 times 6 is 18. Let's try another one. Let's say that x is 2. And in this equation, y equals 3 times x plus 5. Then x is going to equal 2. And 2 plus 5 is 7. That means that y equals 3 times 7. And 3 times 7 is 21. So y would equal 21. Okay, let's try yet another problem and see how you do with it. Here we have y equals 3x minus 5. So here it is. We have y equals 3x minus 5. And we're going to substitute this value for x. We're going to say y equals 3 times minus 1 minus 5. And that means that 3 times minus 1 is minus 3. And minus 3 minus 5, if we put those together, we're going to get a minus 8. So y equals a minus 8 when x is a minus 1. Let's do it again. Let's say if y equals 3x minus 5 and x equals 0, then what we have is y equals 3 times 0 is 0. 0 minus 5 equals a minus 5. And what does y equal? It equals a minus 5. Let's try another. Here we have x equals 1, positive 1. So we have 3 times a positive 1 minus 5. Therefore, y equals 3 times 1 is 3. 3 minus 5 is a minus 2. So y is a minus 2. So what have we done? We've substituted. We've substituted values for x, and we found out what y equals. And I'd like you to get some practice doing this. I'd like you to do some problems. This is the Learn Math Quickly Workbook 4 Algebra. Please do some problems on pages 40 and also page 50. And come on back, because we're going to be doing something called graphing. Now remember to check your answers at the back of the chapter, and then come on back for graphing. Welcome back to graphing. Now take a look. We have a graph here. This line here is called the x-axis, and this line here is called the y-axis. Now, I want to tell you something about this. I want to tell you that this is a number line. Here are your negative numbers on the x-axis, and here are the positive numbers, and they intersect at 0. That's where they meet. Now, this line here is called the y-axis, and this is also a number line. Here are the negative numbers, and here are the positive numbers. And these points here are called, here is called an ordered pair. The first number corresponds to the x-axis, and the second number corresponds to the y-axis. So if I'm looking at the point -2 and a +3, what I need to do is remember the first number corresponds to the x line, and the second number corresponds to the y line. So I'm going to look for -2 on my x line, and here it is. And then I'm going to look for a +3 on my y line, and here that is. And then I just trace it up like that, and that's the point 2, -2, 3. This is called graphing points. So let's take a look at another one. Here we have a -2 and a -3. The first number corresponds to the x. Here's the -2. The second corresponds to the -3 on the y line, and here it is. And what I'm going to do is I'm going to go like this, and there's my point. I chart my point, -2, -3. Let's take a look at another point. Here's one over here. This is 6, 2. 6 corresponds to the x, 2 corresponds to the y. What do? They meet right here, and that's where I draw my point. So how do you make a graph? You make an x, you make a y line, you make an x line, you put in the numbers equidistant from each other, and when given a point like this, you find first your x and then your y, and you find where the point is on the graph. Let's take a look at this ordered pair here. It's 2 and a -3. The 2 corresponds to the x, the -3 corresponds to the y, and here's where the point meets. It's a 2, -3. So this is a graph, and this is how we graph points. Let's take a look at another graph. You ready? Okay, here we have another graph. We have the x-axis and the y-axis, and now we've kind of connected the points, and we have a line. And take a look. Where the line intersects the x-axis, that's called the x-intercept. And this point right here is 2, 0. That's the ordered pair. And over here, this is where the line intersects at the y-axis. And that's called the y-intercept. It's where the graph line crosses the y-axis. And this point is 0, -3. So we have x-intercepts and we have y-intercepts. Now let's take a look again. Lines have slopes. If you've ever been skiing, you know that. They have a slope. And a line that goes up from left to right has a positive slope. And a line that goes down from left to right has a negative slope. And a horizontal line has a 0 slope. And a vertical line has an undefined slope. We don't talk about skiing down slopes like this, huh? It has an undefined slope. Okay, let's take a look one more time. Now, to find the slope of a line, the rule is you take 2 points on a line, and what you do is you subtract the first y from the second y, and the first x from the second x. And a slope could be a proper or an improper fraction. It could be negative or positive. So let's take a look here. Let's say that on a line we have 2 points. We have point 11 and point 59. Remember, the first one is x and the second one is y. And what are we going to do? We're going to follow the rule for slope. And the rule for slope says take the second y minus the first y. That's 9 minus 1. Take the second x minus the first x. That's 5 minus 1. And what am I going to get? I'm going to get 8 over 4. And if you divide 4 into 8, you get 2. And the slope of the line is 2. Let's try it again. Let's say we have these 2 points on a line, a positive 3 and a positive 1, a positive 4 and a positive 12. The first number are the x's, the second number the y's. And what am I going to do? I'm going to follow the rule. The second y minus the first y over the second x minus the first x. And here I go. I'm going to say 12 minus 1, 4 minus 3. This is 12 minus 1, the second y and the first y, and 4 minus 3, the second x and the first x. 12 minus 1 is 11. 4 minus 3 is 1. 1 divided into 11 is 11. What's the slope? It's 11. Let's take a look at something else. Here we go. Now, before we graphed, well, actually, before we found out the values, we gave some values for x, and we found out what the values for y are. And remember this? This is y equals x plus 6, and we said that if x equals 0, then 0 plus 6, then y would equal 6. If x equals 1, then 1 plus 6 is 7. If x equaled 3, then 3 plus 6 is 9. And that if x equaled 5, that 5 plus 6 is 11. Remember that? Now, if we wanted to find the slope, we would take 2 points. And I took the points 1, 7 and 3, 9. I took these 2 points. And what I did was I followed the rule for slope, remember? Subtract the second y from the first y. Subtract the first y from the second y. And then we're going to take the second x. We're going to subtract the first x from it. And what are we getting? 9 minus 7 is 2. 3 minus 1 is 2. 2 over 2 is 1. So what would be the slope of this? It would be 1. And now we can go one step further. We can make ourselves a graph. We can take our x and y axis, and what are we going to do? We're going to graph this. We're going to graph the points. Here's the point 0, 6. Here's the point 1, 7. Here's the point 3, 9. And here's the point 5, 11. We find these points, 0 and 6, 1 and 7, and we put them in our graph, and then we draw a line to kind of connect the dots. And this line would represent the equation y equals x plus 6. Can you tell me what the y-intercept is? That's where this line crosses the y-axis, and it's right here. It's 0, 6. So I'd like you to get some practice doing this, graphing problems. If you would, please go to the Learn Math Quickly Workbook 4. Try pages 41 to 45, that's part 1. Pages 51 to 55, that's part 2. And then check your answers and come back for some algebra word problems. Let's do some word problems using algebra. Take a look at this problem. Jack works twice as much as Joe. Together they work 120 hours a week. How much does Jack work? How much does Joe work? Let's make Joe, we're going to make Joe x. And we're going to make Jack's going to be 2x. Now, let me tell you something. If Jack worked 6 times as much, it would be 6x. If Jack worked 2 hours more, it would be x plus 2. If Jack worked 2 hours less, it would be x minus 2. So the numbers are around Jack with this twice, and that's why I make Joe x. Now we're going to combine this. We're going to say x, that's Joe, plus 2x equals 120, because together they work 120 hours. So x plus 2x equals 120, and x plus 2x is 3x equals 120. And what am I going to do? I'm going to divide by 3 on both sides of the equation. This cancels out, and I find out that 3 into 20 goes 40. And that says that x equals 40. So Joe works 40 hours, and Jack works 40 times 2 is 80 hours. So 40 and 80. This is an algebra word problem. Let's try another one. Are you ready? Here we go. Okay, let's erase the board first. We have Sally types 20 words per minute more than April. Together they type 200 words per minute. How much does Sally type? Let's make April, she doesn't have any numbers surrounding her, let's make April x. And let's make Sally x plus 20. So together together it's 200. They type 200 words per minute. So we have x plus 20. This is April, this is Sally, and it equals 200. And what are we going to do? Well, we're going to say x plus x is 2x, and 2x plus 20 equals 200. And then what are we going to do? We're going to add actually a negative 20 to both sides of the equation. This cancels out, and then we find out that 2x equals 180. Now, if 2x equals 180, if we divide by 2 on both sides, we find out that x equals 90. So guess what? April is x, April is 90, and Sally is x plus 20, which is 110. Okay. Now, let's try a different kind of word problem. Let me erase the board. Let's try something called distance. What about distance? Well, distance equals rate times, oh, I don't even need that, rate times time. Distance equals rate times time. Helen averages 60 miles per hour. How far will she drive in 9 hours? Distance equals the rate, which is 60, times the time, which is 9. And that means that distance would equal 60 times 9, or 540 miles. 540 miles. Now, you can write this formula in different ways. Let's take a look. You can say that, you could say rate equals distance over time, or you could say time equals distance over rate. Okay, the formula can be kind of switched around, looks like that. So let's take a look at another problem. It says, Louise is traveling at 65 miles per hour and she's going 585 miles. How long will it take her? Well, we're looking for time. So time is going to equal distance over rate, right? Time is going to equal distance over rate. And how are we going to set this up? We're going to say that the time is going to equal 585 over 65 miles per hour, huh? And so if we divide this, we're going to find out that the time would be 9 hours. 9 hours. So this is distance formulas. Let's take a look at yet another type of algebra word problem. And this one has to do with money. Interest is money you earn on your money in the bank. And simple interest is interest on the principal amount, the money that is deposited, that you deposited, or the money that you borrowed on a loan. And the simple interest rule is interest equals the principal, that's the money that's deposited or borrowed, times the rate. Now, that's the percentage rate, and it's written like a fraction or a decimal, times the time, and that's written in years. So interest equals principal times rate times time. So how much interest, we're looking for interest, will Sylvester earn on $500, that's your principal, $500 deposited for 3 years, that's the time, in a savings account which earns 3% simple interest. Now, to change a percent, do you remember to change a percent to a decimal, you go like this? And to change a percent to a fraction, you just put 3 over 100. I'm going to work with the decimal, so let's times 500 times 300 times 3. Now, 500 times 300 is going, 300ths is going to give me 15. So the interest is going to equal 15 times 3, or 45. What did I do? I multiplied 500 times 300ths, and I got 15. Remember, you have to count your decimal places. And 15 times 3 is 45. So how much money? How much interest? $45. So what I'd like you to do is I'd like you to have some practice. Try some of these problems. Go to the Workbook 4, Algebra, pages 46 to 47, that's part 1, and pages 56 to 57 is part 2, and check your answers in the back of the chapter, and then you can try test 1 is page 58, and test 2, page 61, and then come on back and let's continue because we're going to be going to video 16, which is more algebra.